Let's go ahead and get started. So, network access control. What does it mean? What is Cisco ISE? Title there pretty much says it all, present and future. Again, as I mentioned a few moments ago, I'm with High Tech Network and Security Solutions. The university contracted us a little over 3 years ago to assist the university in a proof of concept bake-off for network access control to replace their current system. We baked 2 systems off and then implemented the solution that won that bake-off, and I've been supporting it for the last 2+ years. The purpose of today's presentation is to discuss to varying degrees in some level of detail what ISE looks like today and what it's going to look like tomorrow. What is NAC and why do we call it ISE? You'll hear people refer to those two terms interchangeably. NAC is exactly what it said on the opening slide, access control. What it means is allowing for some level of authentication before you gain network access. Okay? Even if you've failed some level of authentication, you will have access. How is that different on the wired side than it is wireless today? Anybody here who's worked with an end user who cannot get authenticated on the wireless side? Raise your hand. Just what it sounds like. You got nothing. You get no access whatsoever. On the wired side, you will be starting on a default VLAN. More on this later in greater detail. You will be starting again on a default access VLAN. It will give you some measure of access. Not as much as the student or staff member may like, but it will give you some measure of access. That's going to tell you right off the bat, okay, I may have failed NAC, but at least I know I have network connectivity. Cable's good. Port's good on the switch. NIC card's good. Okay, what am I battling? I'm battling something that is likely beyond physical media. What is NAC? Why do we call it ISE? As I said, NAC, Network Access Control. ISE is Cisco's Identity Services Engine, and that is the product that the university has selected to provide network access control services for what started out as a wireless and will now be just about every single port on the university. That was all the easy stuff. How does it work? That's a little bit more involved. ISE is an authentication system that takes information provided to it and it typically will forward it to an authenticated radius source. In this case, for the university, the majority of the time is Active Directory, for things like, is that the right user ID? Does that user ID exist in the domain? Is that the right password? What group attributes do they have? What OUs are they a member of? What groups are they a member of? What it can do with that information is exactly what we tell it to do, which is to say, if you're a member of a particular OU, then you're going to get a particular network assigned. We're going to do that with what we call a dynamic VLAN push. VLAN, Virtual Local Area Network, another engineering name for subnet. Security, as it's continued to evolve here at ASU, is more and more heavily focused on user segregation, and ISE is a central player in that. The most important part of that, however, is the firewall. That firewall is going to make a determination on what address space is allowed to access what other address space. Okay, I'm talking about IP addresses. So, if a student who lands in the student VLAN based on their roles and credentials is authenticated completely, wired or wireless, they will be able to get to everything that security has said this is what the student needs. If, however, the student is, let's say, a student worker, should have a level of staff access, but their EDNA role has not been updated, it's not going to put them into that staff role. Things like today, printers, they won't have access to them. They won't be able to print. Again, more on that later. But at a high level, that's a use case that we'll be focused on when it comes to talking about troubleshooting something, how something is supposed to work, why it may work, why it may not work. What it is doing for ESU today is authenticating to the extent that we have it set up, users that are getting on the wireless network. Now there are 3 SSIDs here at the university. 2 that belong to ASU and 1 that is a shared or extended. Anybody know what they are? Yep. Now, all of them use, to varying degrees, they use ISE. ASU guest and eduroam will use Active Directory to validate your user ID and your password. Excuse me, and your group permissions. Once it authenticates you, it looks at its rule base and says, okay, you're a staff user. I am going to change your VLAN, push it to the wireless LAN controller, and put you in that address space that allows the staff user to go anywhere they need to go. You're a student user, it's going to put you in a different VLAN. And the access for that, as of the spring, is slightly different. Again, more on that here in a few minutes. What is ISE not doing? This is an area that you're going to hear me repeat a few times today. What ISE does not do is it does not play a role in any way, shape, or form in your ongoing communication. Okay? You are talking to the wireless LAN controller via the access point that you're connected to. It has forwarded your authentication request to ISE, who has then in turn forwarded it to Active Directory, specifically to one of 2 domain controllers in today's architecture. That domain controller has responded with a thumbs up or thumbs down and a list of attributes. In one particular area, we are looking for group membership. You are part of NAC users or you are part of NAC trusted users. You are part of NAC users and you have a good ID and a good password, you get on the network. If you are part of NAC trusted users, you get on staff. You are on the same SSID, but you are now issued a different VLAN via dynamic push when ISE gets its information back. At that point, you are free to roam about the country to shamelessly plagiarize the Southwest commercial. Okay? The only point in time when you're going to interact again with ISE is if you are wandering the halls, a dorm, or campus as a whole, and you re-authenticate. And if that's going on, you are likely unaware of it because it's automatic. It's taking your cached or saved credentials and it's going, hey, user A just jumped APs. He's re-authing. It should take place in microseconds. Okay? The only time you're going to see it is if you have to be sitting in a place somewhere on campus where the wireless coverage may be poorer than others. Or you're sitting in a spot where you're dead smack dab in the middle of 2 access points. And the access points are running something called clean air. So they're powering up and powering down based on interference that senses from other APs in the area. And so the signal strength for the AP you're connected to may drop based on power. Suddenly you hop over to the next one. And you may see this. Okay? Regardless of that happenstance, ISE is not in any way, shape, or form playing in your traffic flow to the internet, to an app server, to a printer, to anything. Okay? It does not care what you do once it authenticates you. The wireless LAN controller is no longer talking to it. The only time the wireless LAN controller is going to talk to it is if you become disconnected and attempt to reconnect. That is an important distinction for this reason and this reason only. If you are sitting in front of a user and you are seeing them disconnect and reconnect repeatedly, ISE is not doing that to you. ISE is going to allow you on or not allow you. Now, your device is going to continue to try and reconnect. Okay? So, in fact, you may be failing authentication. But if you are on for a minute, 2 minutes, 5 minutes, and then disconnected, ISE did not suddenly go, I don't like you anymore. I'm going to disconnect you. Again, important distinction. There is a system and a process by which we blacklist users. Everybody here experienced that. What that basically means is that ASU Security Operations Center, run by Dell SecureWorks, has detected your machine or your user's machines doing something it should not be doing. So what they typically do is they've got their own internal process by which they attempt to contact the user over a period of 7 days. And on day 8, they send a ticket to us, and they ask us to blacklist that user. What that basically means is that when ICE gets that request for that device, not the user, the device, again, important distinction. When that device attempts to authenticate again, ICE says, yeah, you're on my bad guy list. I'm not even asking Active Directory. Don't care. Your machine's bad, and I'm going to tell it, go away.
And what's the identifier used for the device?
The MAC address.
I just want to clarify.
Yep. MAC address. And that's what we do on the blacklist side. Okay. There are other identifiers of devices that may be good information to have. Machine ID, if it's a device that's doing machine authentication. If you don't have the MAC or you can't find the MAC, we can find it with the user ID. Who's trying to sign into it. It's going to tell us via Splunk. Hey, key caller just tried to sign in on this device and it failed it. Why did it fail? Splunk very clearly says, because he's on MAC blacklist. Questions on either of the two slides? So I've kind of covered a little bit of a high level of some of the deeper details that we're going to get into here. At any point, and I'm going to try and pause after every slide, but at any point if I say something you want clarification, you need a repeat, or you just simply don't understand what I just said, please stop me. And I'll apologize now, that's kind of hard to read. Yeah. Pop some no. The lights. All right. So, wired authentication. Cisco ISE, what's next? Before we get to what's next, we've kind of covered a little bit about what we're doing. Okay, and again, to repeat that, we are currently doing wireless authentication. .1x is something we haven't talked about, something I'm sure at least to some of you will strike a chord, and that is MAC address bypass. Okay? At the end of the day, if you are joining ASU SSID or ASU guest, you are either providing an ASU right ID and password, or you have registered your device through My Devices portal, someone has registered your device for you through the sponsor portal, or you have sent a ticket with a list of devices to HITECH to have them place their MAC address bypass as a trusted device. So, 2 years in counting, we're now moving into wired authentication. As a general statement, non-dorm room switches will be configured to use .1x. Now, again, that is a broad, sweeping, and general statement. That is not 100% accurate. For the purposes of today's discussion, you can treat it as gospel. What does that mean? That means that just like on the wireless side, devices that are plugged into a .1x configured port on a network switch anywhere here on campus.
A couple of folks online are saying it's a little difficult to hear you when you're on that side of the room.
All right.
Well, I can hear you fine when you're
stay over here. Okay. And I'm going to pace, so you'll have to remind me.
And a couple of questions.
Okay. If a device is plugged into a .1x port, it's going to ask that user for credentials. Okay. Same way as it does the first time for wireless. It's going to take that configuration profile if you already have joined and use those cached credentials to connect. It will make the same determination that it does today on wireless based on Active Directory membership, valid user ID, valid password, and group membership as to what VLAN to assign you. And when I say you, I really mean that switch port. Okay? Now here's an important distinction again, between wired and wireless. .1x for wireless is been around a long time. It's really well baked and is standardized all the heck of it. The .1x on the wired side will present some additional or unique challenges. Not the least of which is that some devices that are wired in do not like to go through COA, or what we call change of address. Now, why is that important? I mentioned a moment ago that if you fail .1x on a wire connection, you're still going to have some network connectivity. Okay? It's going to be very basic. It's going to be internet only for all intents and purposes, but you will have some network connectivity. Now, that may be because you failed off. It may also be because the device did not understand what it needed to do when the VLAN changed on the port. What it should do is go down, come back up, request a new DHCP address, get a new IP address on the VLAN that ISE told the switch, hey, put this user on. They're a staff user, they're a student, they're a guest. And it didn't do that. So now it's, for all intents and purposes, kind of dead in the water. It'll cycle again once it realizes, hey, I don't have network connectivity. User may have to unplug or replug, and they will do that, or they may reboot. We don't have a solid fix for that issue. We haven't seen it a lot, but we will see it, okay, especially with older devices. Pilot sites are being scheduled. Stephen was, in one sense, lamenting, in another sense, acknowledging earlier that the dorms are going to be some of the early pilot sites. We have been working on these pilot sites really since last fall, identifying the different use cases, doing slow rolls for some of the VLANs and some of the configuration. We've done a great deal of testing. So we're going to roll these out over a period of a couple of months, make sure that everything goes well. We'll basically be treating these as proof of concept sites, understanding what we need to come be better prepared to do or deal with, or if there are things that we can do better on initial rollout to address some of the issues and challenges we run into. After that's accomplished, we'll be deploying this in a much more rapid fashion. The goal here is twofold. Identify the users and make sure they have the access they need, but no more than they need. I want to start with the users online, Joe.
Yeah, sure. There's a few questions here online. I'll read them out loud so that the audience can hear. From Jimmy Kurtz, is MAC address bypass ASU guest only or ASU as well?
At this point in time, it is ASU guest only.
Another question from Lincoln Slade. How will this impact systems on a non-managed switch?
On a non-managed switch, if there is a, let's say, a 4-port hub or something like that, in a dorm room, that device will be plugged into a non-.1x port, specifically on VLAN 3540. For devices that are plugged into a non-managed switch behind the .1x port, that port will be converted to whatever devices initially authenticates to the switch.
Okay. Matt Brown, domain joined lab machines for regular students that have access to shared CIF space. Do they have a logon and then connect to SSL VPN for access to CIFS space?
Like for trying to access a network file share.
Oh, okay, file share, okay.
So if the device is a lab machine and everything is set up the way it's supposed to be set up, that device is either is likely MAC address bypass today. There should be an effort to convert those lab machines to machine authentication. If they are machine authenticated, then they are on staff. They are on the staff VLAN, and there shouldn't be any restriction to what the students who are signed into those can get to. Regardless of the fact that a student is signed into that machine, it's going to remain on the admin VLAN of the staff VLAN.
Right, so just to clarify that, for lab-based machines that are, as long as they're domain joined, that information is fed to Jim and the project team as part of that, usually through SCCM or through AD. So if it's an authorized machine that's on the domain, it will authorize in NAC by the machine, not by the user. So if you change a machine or you take the machine off the domain and then try to put it back on, maybe you rename it and it has a different name, then you're going to have a problem. If you don't let them know that here's this new machine.
And that machine, the machine authentication in terms of ISE is looking at a particular OU what that machine should be a member of. So you have access, or if you are the domain admin for your OU, or you have access to that person, then you can put that machine name or have them put that machine name in that OU, and your right is right.
Couple more questions.
Okay.
How will this impact printers?
This is not going to impact printers. The printers will, as part of this, a little bit we'll call it derivative, the printers are going to be landed in what is a static VLAN or VRF. This was a direct result of the security walls coming up between 3500 and 3520, euphemistically staff and students. And the students no longer being able to get to the printers or the print controllers, print servers, I guess I should say. Staged myself a bit there. So the short version, it will not. Once the admin, or I should say the static VRF is deployed and the printers are moved into it, the security rules will allow printing to those IPs. There will be less security involved now.
And how will it impact AV equipment?
AV equipment will also likely land in a dedicated or unique VRF for the same basic reason. Right now, most of the AV equipment that's in use around the university does not support .1x. They are specific types of tablets which are not really network devices. What we have done and what we continue to do right now is MAC address bypass them, which based on current rule set lands them in 3520. Again, the security rules that changed this spring, bringing a fairly significant wall up between 3500 and 3520. The devices could no longer access the controllers that sat in the data center. So that was what drove that decision.
I think another component of AV equipment would be digital signage. There's quite a lot of network digital signage throughout, and I think it's a mix of non-802 and some that do have 802, depending on the age of the machine usually.
The end-state goal is not to necessarily put a name to every device, although, if we get to a higher level than we currently have, that will make the security office a great deal happier than they currently are. What that basically, though, does mean is that we are going to come up with individual use cases like digital signage, like printers, like audio-visual equipment, control pads, projectors, things that are networked and controlled via remote tablet or a panel embedded in the wall that will need to communicate with outside things. Something as simple as controller access is easy to accomplish. Other things like hey, I need to update these, and it needs to go out to the internet to be updated. I'm not going to use it to browse the internet, but it does have a button here that says, check for latest firmware. We need to make sure that works. Do you have a question, Max?
So that's the same like a lab machine that is now part of Active Directory.
Correct.
Or like Linux or etc. Even a Windows box that's not part of Active Directory. It's part of an instrumentation.
Yeah, and in fact, we had a what's your name?
Al Thompson.
You and I spoke last week, didn't we?
Sure did.
Or 2 weeks ago. So that's a great use case. In fact, if you don't mind my sharing that, I'm gonna bring it up to the team. So Al opened the ticket and did land on High-Tech's desk to execute. We saw language in the ticket that said, oh, this is a lab machine. So we said, oh, you should go put your device in this OU. Al called and said, hey, okay, maybe we're just not speaking the same language. This is a lab device, but it's not a lab the way I think you mean lab. This is a device that's not the main joint. Hell, it's not even a Windows device. It might be a Raspberry Pi. It might be something that has no way at all of using .1x. How do I get this thing on the network? And the answer to that, anybody want to take a crack? Except you, Al. Mac. He was right. MAC address bypass. Al's next question was, okay, great. What language do I need to use in this ticket to make sure that I don't go a week without getting stuff online again. So we shared that. That's all information that's out there in the knowledge base articles and that the service desk should also be able to help you with. However, perfectly okay for you guys to call into the service desk if you don't see something being done in a ticket and go, can you conference in the guys at High Tech? Something's not happening here, and this really isn't that hard. And all that was a simple misunderstanding. Any other questions online, Jim?
I just lost my connection.
Yeah, it's, so Jeremy Curry says, so non-domain joined machines or devices that would otherwise not be an AD will either need to be registered or on non.1x enabled ports, correct?
That would be correct, Jeremy. They would need to be registered if the devices are plugged into a .1x port, be able to get past the security, or be on a non.1x configured port.
The next question is asking about the documentation for these processes, so pre-provisioning for imaging.
I'm going to let you take that one, Jim.
Yeah, it's, we have a website. It's available, wifi.asu.edu. Going back to what Tony said earlier, this is something that was created and made available when we went live with the wireless side back in 2016, about 2 years ago. So you should be able to find what you're looking for there. We're currently working with the team. Most of that is centered around, almost all of it's centered around wireless access right now. We're working with the team to update that site to also provide knowledge base articles for wired as we move forward. So wifi.asu.edu, I'll put it here in the chat as well.
All right, Lincoln, reading your question about MAC address or Linux systems that are joined in domain. Largely at the discretion of the support you're going to get on the .1x client or the interface card that's on that machine. If it supports machine authentication or being configured to use machine authentication, and the machine name is in the group, then it'll be able to machine off without user ID. Otherwise, it will need the MAC address bypass, or individual credentials will need to be supplied when it when someone logs into it to enable authentication.
At this point, who do we send requests for to get machines put up on bypass?
You can open those tickets and assign them to the high-tech team.
High-tech?
Yep, that is our service desk. Our service now. Put as much information in there as you can about what you're going to do with it. What we have found over the last 2 years is that some users will get frustrated with the .NET configuration on their device and just kind of wave the white flag and MAC address bypass it. Now, is that a big deal? No, we'll continue to do it. Where it's going to cause you problems today following that same process is that device right now lands in 3520 to students, which means it will have restricted access. And it may not have access depending upon its use case, or its role, or your students, your education, your user, as to what it can or cannot get to. Okay? So make every effort, if it's a device that needs unfettered access, to get it online, what I'll call the right way. In the end, if the issue again is it doesn't support it, it's a Raspberry Pi, it's a device that doesn't support machine authentication, I need this authenticated, and we'll get it on.
I'm Tony from Jeremy Kurtz. A little while back for machine auth and AD is that the iStack devices needs to be added to the OU permit group of a particular OU for the controllers to properly read objects. Curious if that will still be the case for wired NAC.
It will be.
Is that again? Repeat that again, please.
The answer to the short question, or the answer to that long question is yes, it will be. So basically, if there was a specific OU that users were putting their machines in to be able to configure for machine authentication, they needed to be pointed at the iStack devices. Needed to be added as what's it called? An OU permit.
All the questions we have.
All right. ICE, how does it work? Acronyms you will hear. Wireless Access Point, WAPS. that which you are connected to with your device. I've cited from it, I've already used that one a few times. That's what the AP is connected to. Ironically, the connection from the wireless access point to the wireless LAN controller via network switch is on a cable. That's about as wireless as it gets. Cisco Prime, or also just called Prime. Prime is that single pane of glass that your current managed service provider, Citronic, is utilizing for a lot of the wireless management. We also utilize it if and when we get a request by the Security Operations Center to blacklist a user. We utilize it to go in and reset connection on a user that's been blocked. So when we blacklist them, we hunt them.
Just to be clear, it can be done both ways. You can blacklist a user by their issue right or by their identifier, or you're blacklisting the device. Which is
Not on.
Right, that's why I was just clarifying. When you say user, you actually mean
Yeah, I
device.
actually mean the device. Thank you.
You are.
Cisco ISE, ISE or NAC. ISE, Identity Services Engine, we talked about that a little bit already. Or NAC, people use them interchangeably. Windows AD, Active Directory, access switches, VLANs and bursts, and endpoints. VLANs and bursts. Spend a little time on that because that's going to be kind of key to what we get into here in a little bit. VLANs and VRFs. So VRFs is we'll call it an overarching segmentation, logical segmentation of the ASU network. Okay? It is, and you've heard me refer to a few of them earlier today, 3500 and 3520 specifically are the two that are most in common in use today. It is an IP subnet boundary environment that the users are slotted into. A lot of things have gone into that architecture, decision-making process, use case and access, as well as things like, why do we need to segment this population from that population? For lack of a better term, treat VRFs as completely, independent side-by-side network. Is there communication that goes on between them? Absolutely. What is the difference between a VLAN within a VRF and a VLAN that is a VRF? I want to take a crack at it? Kind of a complex question, but it's actually really simple. It's got a really simple answer. VLANs within a particular VRF will be allowed to communicate because they're in the same VRF. Okay? It's just a network, it's a subnet. Okay? You're going to hit a layer 3 out point, and it's going to switch you from, route you on the switch port from VLAN number 1 to VLAN number 2. Okay? If you have communication needs between VRFs, that traffic is going to go through a firewall. There is a firewall that sits astride the fusion point between all VRFs. There will need to be firewall rules that say, allow this traffic from this subnet to that subnet on these ports. And it's either port-based or it's app-ID-based. Going back to what I said a moment ago about MAC address bypassing and kind of being the surrender monkey flag for I don't know what the hell to do to get this thing on network, so let's just map it. Will you be on? Absolutely. Will you have access to what you may need to have access to? Depends on what you're going to do with that device. Are you going to print from it? The answer today is no. Are you going to get to things in the data center, specifically in the RC 1918 space, which is blocked now? The answer is no. If you don't need it, then it works. If I just need internet access, or in the case of Albert, hey, I just need to be able to control this device. I don't really care, I just needed to be able to control this asset here, and get in it for it to be online so that it's reachable. Okay, perfect use case. Perfect use case for math. The VRFs and the VLANs are named accordingly. So VRF 3500 is VLAN 3500. VRF 3520 is VLAN 3520.
But within VRF 3500, there are multiple VLANs.
There are multiple VLANs today. Majority of the network is going to be, so those networks are /14s. They're really big IP subnets. There will be VLANs added, and we're going up, as you probably already sensed, in increments of 20. So staff, 3,500, student, 3,520. Dorms, for static assignment, non-.1x, 3,540, something that Steven's intimate with.
And also 3580.
We have 3560 as guest wireless. We have 3580. 3580 is the newest one we have that is germane to everybody here in this room and online that supports endpoints and users. 3580 is going to be the starting spot. And if you fail all means and methods of authentication, the landing spot for all wireless connectivity.
And what do they get behind door number 3580?
Internet.
You can browse the internet.
You can browse the internet.
That's it.
Which means you can, if you've got VPN, you can VPN in, you can access anything that's available online, non-VPN, to the Asian students. If you are a staff member, you're likely not going to get the hardly anything to do your job.
Unless you VPN.
Unless you VPN.
Right, so that's a shortcut for if you have an issue with a machine or with a staff member who can't get in, or they're using a personal device, for example, that's non-domain joined, and they can't get to the network share, or they can't get to whatever, then you tell VPN in,
No.
then give me your machine info so that I can get it on nav or I can get it authenticated.
I wanted to say I have one caveat to all that. You guys are all probably wheels are turning right now. So again, like Tony said, it's the starting spot and landing spot for 3580. Now going back to the starting spot, when you plug in a new device, so we're talking about, like, say you're onboarding a new user at their desktop, right? You have your imaging processes today. We're working with, starting with the UTO team, we're going to reach out to the other teams that have SCCM environments, but we want to make sure that process of imaging doesn't break for your departments. And so that's the one caveat. That's the short-term goal. The long-term goal, I think, is to look at this zone, 3580, and how to properly secure it, and really look at the process of imaging and make sure that those two can work together in the future. But in the short term, the goal is not to disturb your imaging processes with this implementation. Anything you want to add to that?
No, that sums it up pretty well. The only last thing I want to touch on this slide, and I got skipped over a moment ago, is access switches. But I put them on here because you're going to hear them talk about when you're engaged with someone who's talking about .1x authentication. All the .1x config from a wired network perspective is going to exist on those switches. Okay, not the cores, not the distribution boxes, not the super expensive, heavy duty, high power, taking everything, passing everything network infrastructure. It's that 24 port switch at the end of the row, sitting in a lab. It's a 48 port stack that's sitting in an IDF somewhere. Those are the ports that that's where the security exists on the wire connection. All right, current architecture. Right now, data centers are IO and ISTV1. There are 6 UCS hosts total, 3 each data center. There are 2 admin nodes, 2 monitor nodes, and 4 policy nodes. Now, what does that mean? Admin nodes are exactly what it sounds like. That's the boxes that we use to administer the ISE deployment. There's a primary and an HA failover. The monitor node is also exactly it. All the monitoring function for the environment takes place on those. Again, primary and backup on each data center. The 4 policy nodes are the boxes that are doing the heavy lifting. Those are the boxes that take the requests today from the wireless LAN controllers. Tomorrow, we'll take them from wireless LAN controllers and access switches to say, hey, who is this? Is this person someone I should let on the network? This is the environment that's, for all intents and purposes, been in place now for 2 years. We did add 2 additional UCS hosts for capacity, as well as performance, and to support what is the coming architecture. This is the coming architecture. For all intents and purposes, been in place now for 2 years. We did add 2 additional UCS hosts for capacity, as well as performance, and to support what is the coming architecture. This is the coming architecture. Still the same 6 UCS hosts and 2 admin and 2 monitor nodes. We are going to increase capacity to 12 policy nodes. Across both those data centers, that's 6 each. The legacy UCS chassis, that is the old units, will have 3 policy nodes per. So each host will have 25% of the authentication processing capacity for the university. Each of those nodes will process 20,000 concurrent users at any given time. Okay? So we've been pottering along. With 80 to 100,000, users simultaneously connectivity. We have more authentications than that. So how is it working today? Remember, ICE doesn't care what you're doing once you get on the network. It doesn't participate in your communication. So it's not 100,000 devices that are on and funneling traffic through ICE so that ICE can see it. ICE doesn't care. ICE is not seeing that traffic. ICE doesn't participate in that communication in any way, shape, or form. Your literal interaction with ICE is as fast as you open your laptop and see it connect to wireless. Usually 3 to 5 seconds. The 12 policy nodes are going to be split, as I mentioned, across the 4 legacy UCS. In front of those will be a pair in each data center, 2F5 load balancers. What that basically means is that today, the wireless LAN controllers and test switches that are being used for POC wired are firing the authentication requests to one of 4 IP addresses, 2 in each data center. Tomorrow, they will be firing those requests at 2 IP addresses, 1 in each data center. Behind that IP address are 6 nodes that will be round robin, for all intents and purposes, load balanced for who is busy. Okay, again, traditional load balancing in play, for those of you who are familiar with what that looks like, but not in the sense that, again, that load balancer, and by extension ICE, is only going to do your off. So when I say least busy, it's you were busy for a moment and now you're wait. It's just going to scatter those across. What we're currently seeing, and the way that the environment's designed to work, is if you're focusing them directly at a host, as long as that host answers, whoever's talking to it will keep talking. Think of it as a you-know-what neighbor who comes over to the barbecue and will just not leave you alone. Okay? You feel like, I got to kill myself to get away from this guy. Well, that's kind of the way ICE works. Okay? If I'm answering the wireless LAN controller, then the wireless LAN controller is going to keep sending traffic to me until I stop. Okay? So, this is a way for us to be able to take that traffic and spread it across the nodes so that we don't see any particular policy node take a bigger load than it should. The other takeaway here is that future data center is no longer going to the IO, it will be back at the West Campus. Okay? Some things that are going on in the background. Today, the ICE deployment is stretched, for lack of a better term, across IO and ICE to be one in the same network. Tomorrow, they will be in disparate networks unique to each data center, which basically means that it will be forkliftable. I just coined that word. Forkliftable when IST1 is vacated. Questions? All right, quick topology drawing, and for those of you who don't want to stare at this and go blind, we'll make this available. Well, actually, the entire presentation will be available out to service now. But that's basically what the connectivity is going to look like as a user goes from wired switch or wireless LAN controller, the F5s, load balancers, policy nodes. The takeaway here for all of you in the room is there's got to be some really, really significant issues for ICE to no longer be available. Okay? Significant routing problems, connectivity issues, It's engineered to be 100% survivable. And when I say 100% survivable, take a rock and whack a data center, take it offline. With 6 policy nodes and an answering BIP on the F5 available to all wireless LAN controllers and access switches, the user should be completely oblivious to something that just happened. Okay? Now, does that mean that we've not in 2+ years had authentication problems? Nope, we absolutely have. Absolutely had, and we've absolutely had authentication problems that have been across the campus. Okay? The most recent one, which was a few weeks ago, post firewall failover, where the ASU guest SSID wasn't allowing users to join. That's the way it looked like to the user. That's what it looked like to the users. What was actually happening was that the users were authenticating. ICE was coming back and saying, "Yep, that's you have the correct keyed ID and passphrase for guests to be able to join it." Wireless LAN controller moved them to 3560. Wireless LAN controllers moving them to 3560. We had a VLAN change. What happens on the device next? It's a great test for who was paying attention. VLAN was changed. What happens next on the endpoint? Anybody? COF. Change of address. I'm a new VLAN, so I got to request a new IP. So it did. Requesting an IP from a DHCP server was no longer allowed to communicate to that VRF based on some missed BGP sessions and firewall configuration. Actually, I don't think it was firewall configuration. I think it was just BGP config between routers. Worked over the primary firewall when the secondary took over because of a failover event. BGP sessions didn't reestablish. You couldn't route from VRF to VRF. So what did it look like to the users? I can't get on. Network is down. Guest is down. Can't get an IP. Guest wasn't down. You could see it. You could connect to it. You could actually even authenticate to it. You just weren't getting an IP address when you authenticated. Okay? Now, to those of us in the room, okay, fine. That's a great technical reason for why the network wasn't really down. But the user experience was, I can't use this. So, most of the marketing fluff there, HA, scalable, blah, 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 additional deployment 4, load balancing coming, resiliency, scale. Troubleshooting tools. How did we find that issue? How did we find when SAC called and said, hey, guest is down here? And then it was, well, actually, guest is down here too. And within about 30 minutes, it was, actually, no, guest is just down. What happened? We used Splunk. We used Splunk to identify the fact that the DHCP request was coming. The wireless LAN controller was sending it over. The info box was answering, was sending it back. It was on the right network, yet the device wasn't getting it. Clearly identified a routing problem. It didn't take CenturyLink very long at all to find it. We use ISE as well, even though ISE is logging to CenturyLink and ASU's Splunk. Okay, we will log directly into ISE to look at what it may or may not be doing. It's going to give us a lot of things in a very nice, clean format that you've got to work a little bit to get out of Splunk. But things like total authentication failures and the reason why. Cisco wireless LAN controller. When you have a particularly persistent host that is not joining, and it's not manifest as to exactly why in Splunk, despite all the logging that's going on. Doing a client debug on a wireless LAN controller with that asset, trying to connect and authenticate is going to tell you every single thing you need to know about what's going on. Literally spells it out in nearly plain English. Certainly plain English if you're used to looking at it. We'll be taking logs from the access switch as well. The most important item on this list now is Edna and Active Directory. At the end of the day, MAC address bypass notwithstanding, if Active Directory doesn't have you, or if you're using the wrong password, it's going to fail. Edna is important because that's where your roles and your group membership is populated from scrapes. And when the security came up between 3500 and 3520, that was where we found student users specifically who were guest workers. What's the role, Stephen? Is it they're student workers or students?
Like desk assistants.
Yeah, things of that nature.
Yeah.
There was a whole group of folks that were doing some work for a particular department that were accustomed to having access to whatever they needed, and no reason they wouldn't have, because in those days we were doing segmentation between users, 3500 and 3520, but there were no security rules. It was a distinction without a difference, to point of phrase. Suddenly there became a difference, and that difference was at a high level. Most of the RC 1918 space was blocked going into the data center. And I know I've said that a couple of times, so let me ask, who understands what I mean by RC 1918? RC 1918 is non-routed space, euphemistically called typically called private address space. 10.0.0.0/8/192.168/16 21 slash 20 slash. I don't even remember.
That's basically everything inside the ASU network.
It's inside this network. It's also inside every other network on the planet. Okay, it's not routed on the internet. So there's a CIDR block that's assigned to the data center for DC ops, and that subnet, for all intents and purposes, is blocked.
A quick note on this, it shouldn't normally be a problem for your student workers, because most of the time your student workers will be logging into a domain joined machine. But if you have a student worker who didn't onboard properly and they're not in your AD structure as staff, and they try to log on to a non-domain joined machine that isn't doing machine auth, they'll be able to log in, just like if they did an AD backslash or an ASU AD backslash and logged in. Now they don't get access to network resources if it's a non-domain joined machine. So,
And that was the realized impact. Right? Okay. And we found out, like, well, all right, so why? I mean, these people should be staff users. Why aren't they staff users? When someone went and looked in their Edna role, nobody ever moved them. They hadn't needed to before. I mean, they should have. That was processed, but they didn't need to from a network access perspective. Now you need to. More on the tools. Splunk, University of the Splunk system. Most of the source desk folks have access to a query tool, a GUI written by the Splunk admins to be able to look and see, quick and dirty, why a device might be failing. Sometimes the error log isn't as easy to read or easy to understand as others. Okay. For instance, if the device is being blacklisted, it says, yeah, device failed based on blacklist. Okay. They have a process by which to fix that. Okay, they're going to send it over to SOC. SOC's going to look at it and go, yeah, we never heard from the user, or, yep, we did hear from the user, we're opening a ticket to high-tech to get it unlisted. However, if the device is configured to use a particular authentication mechanism via .1x that's not supported, like LEAP, which you will see, LEAP is insecure. LEAP is not allowed by profile. So if the user device is using LEAP to connect, it's going to fail. If the device is continually restarting sessions and maybe hopping from policy node to policy node to policy node, the policy nodes, and I want you guys to pay particular attention to this next statement, policy nodes are not stateful. For those of you who are familiar with what stateful means, it basically means that any system what that basically means is they are not aware of one another. If you connected and are in the process of authenticating through policy node number 1, and you are wandering, and you go to an AP, which is on different WLC, which then connects to policy note number 3. Policy note number 3 has no idea that you were in the midst of authentication. He does not.
We begin the Valley's only 11 o'clock newscast with breaking news right now.
You're going to send him a frame because you don't
barged into a man's home
Your
and they
device is
shot
going to
him.
send him a
Police are
frame and
telling
he's
us
going
it
to
all
go,
happened around 9
that's
this
like a
morning near
mid-conversation,
59th Avenue
which
and
I wasn't part
Cactus.
of
The
the
victim
beginning,
is
so
in the
click.
hospital right now and is
Give me
expected to
again.
be okay.
Start over.
Police are still gathering information
see
about
that
what
in
happened,
this
but the victim did tell police 3 men
Authentication
robbed him
of a
before
problem, per
shooting him.
se.
We're waiting for police to
Okay.
give us a description,
In
and
terms
as
of
soon as we
authentication,
get that
might
information,
mean the
we will
user's
bring
mobile.
it to you.
And
also
more
mean that their coverage is a little suspect. Perhaps they're sitting
Open
in a
right
spot
now
where
for you to go and cast
jumping
your
around
vote
from
or
AP to
even
AP
drop off
based
your
on-
ballot.
Yeah, many of you are calling in, emailing us here at ABC 15 saying you were turned
Just about
away.
every
You were
system in
unable
the
to vote
university
this morning
lost.
because of technical difficulties at your precinct. Is that
everything that we're
what
going to
it
be
was?
Oh,
interested
certainly,
in
and ABC
terms of
15's Megan Thompson
troubleshooting,
is joining us now
connectivity, and
live. Megan, I
authentication.
understand there are quite a few frustrated voters. What have you learned?
Well, Stephanie and Dan,
Seems
we
like a good
just
place
heard
to
from the
stop
county
for a
recorder. He
moment.
says
Anybody
there are
have
more
any
than
questions?
500 voting locations, and they were supposed to be
online.
more than 100 contracted employees who went
Other
around and
factors,
actually
issues
checked
that
these
impact
sites. It
user
turns out
experience. As I
about
mentioned a
30
moment
of
ago,
these employees
active directory groups,
never showed up.
right? Will it prevent you from authenticating? Probably not if you're using the right ID and password. Okay? What it may do now is it may interfere. No idea that you were in the midst of authentication. He does not have the ability to pick that up. He's going to start you over. You're going to send him a frame because you don't know. Your device is going to send him a frame, and then he's going to go, yeah, that's like a mid-conversation in which I wasn't a part of the beginning. So click. Give me again. Start over, please. So you will see that in his phone. It's not an indication of a problem per se. Okay? In terms of authentication, might mean the user is mobile. Might also mean that their coverage is a little suspect. Or perhaps they're sitting in a spot where they're jumping around from AP to AP based on any number of things. Just about every system in the university logs to Splunk. Okay? Everything that we're going to be interested in terms of troubleshooting, connectivity, and authentication will definitely log to Splunk. Seems like a good place to stop for a moment. Anybody have any questions? Anything online? Okay. Other factors, issues that impact the user experience. As I mentioned a moment ago, Active Directory groups, right? Will it prevent you from authenticating? Probably not if you're using the right ID and password. Okay? What it may do now is it may interfere with
Pixie booting. Somebody's asking about pixie booting. Which is exactly the problem, which is why they're building out a separate component specifically for imaging, because pixie boot doesn't work.
The user experience, however, as I've alluded to a number of times, may be different now that there is more and more and more security being placed in between VRFs and VLANs. Okay. The device support for .1x, I mentioned earlier. On the wireless side, tried and true, early adopted, and really standardized. There aren't too many devices that are, we'll call them endpoint devices that are are designed to use wireless almost as often in entirety, means of connectivity, that don't support every different feature and option of .1x. However, if you've got a circa 2005 or 2006 Samsung, it may or may not have all of those bad features and functions, right? It may not understand what PEEP is. It may not understand, the ability to, adopt a particular setting. The ability of the device to dynamically change IPs, that COA that I mentioned earlier. Okay? A device may not be able to sense, hey, I just had I just got a COA request from Switch. I need to re-request the DHCP.
Interesting question there. Users that remote into their work machines will need to modify the computer name to include the VRM.
That is a great question. I do not know. I don't believe so.
And then just to address the pixie booting for the group and for the people online, can you address what change, or can you just confirm that there are methodologies that have already been tested that will make sure that pixie booting does work for imaging as part of the wired NAC process?
Yeah, I mean, we're working with really with the UTO SCCM environment right now. So folks, Tim Gully, and we've actually tested with one of the members of Stephen's team, Daniel Palmer, and a couple other folks to test out their, so we've installed 3580 and 3500 in the wired NAC environment in a couple of test locations in different buildings. We've been working with them to test as many use cases as possible, and I think the most critical of all of them, it really is imaging. And we're still working through some issues, some slowness we're seeing with the overall imaging process, but I think we're getting very close to having resolution on that. I think I mentioned this earlier, we are aware that there's other SCCM environments out there, so the project team will be reaching out to you in due time to get it, to make sure that we set up a test environment, we test with you all, make sure that, again, like I said earlier, that we don't break imaging as we roll this out. And if we need to make adjustments or if there are issues that come up, then we'll work through those. So as one thing, I guess, to talk about is really the methodology we're using for deployment. I was mentioning this to someone before the meeting got started today. 2 years ago, when we implemented wireless NAC, it was a turnkey implementation for all campuses, all buildings, all campuses. NAC, basically wireless NAC went live, and this will be more of a phased implementation. We, because of the physical nature of it, as Tony was saying, this impacts the access switch. We'll be going building by building. So what you'll see is in the very beginning of this migration, there'll be only a few buildings that are functioning on the new wired NAC. The remaining buildings will be on the old way, and as we move through from building to building, then that will get a little closer to the finish line, but at the very end, we'll have all buildings converted. So as we do that, we'll work to identify who are the right support groups for each building, like we have been with Res Life, even getting other parties involved, like ACC is necessary. Desk side support, classroom support, because Res Life buildings have some of those groups involved as well. So sometimes it is a little bit like finding a needle in a haystack to see who's involved with what building, but that's the challenge that we have. And that's one of the reasons why we are trying to reach out to all of you with today's presentation and also coming to TAG last Thursday.
So to summarize what Jim said too, the intent here is obviously not to take away features, functionality, or service. Okay, that goes for the users as well as folks that are engaged to support them. When we first started discussing this, one of the early challenges identified was imaging. How are we going to image? And we floated ideas around for everything from a process, right? Not a technology deployment, but a process change by which switches we made available would be plugged in to identify ports of an IDF that would extend a non.1x port available within the lab or within wherever the user happened to be. There was no obvious thrill on the part of the staff that we were talking to on the imaging side and said, yeah, I don't really want to pick these boxes up and ferry them across campus. We really prefer not to move them. So how do we image here? How do we image right where that box sits? So the challenge is taking a device that's plugged into a port that is only designed to do one thing, and that is authenticate you. And if it doesn't authenticate you, then it gives you a modicum of internet-only access, which should allow you to, at minimum, raise a ticket or be able to go look up some information, troubleshoot your own computer, or just, as Stephen said, just VPN in and not worry about why this thing didn't work today for whatever reason. When you start doing something as complex as trying to support imaging on that particular type of port, it is, okay, well, help me understand what needs to be open then to the systems that sit in the data center. Nobody really had that information. So we do what engineers do. We tried it to see what was blocked. And what we ended up with was a litany of things that were blocked, not just inside, but also out to the internet. Things that from a security perspective were like, okay, yeah, well, there's a reason why we don't have this open. Can we open it? How do we open it? and the process has been, okay, we do it, we test, we think we have everything open, okay, let's do it again, let's test it again. The challenge with that particular type of problem solving and solutions approach is that, and I said this last Friday on our weekly call, this will all be well and good. We'll get it fixed. We'll get it fixed the day before Microsoft changes something. That's not going to do. Okay. And I'm going to blame Microsoft. I'm going to say, hey, we updated SCCM. Now it uses a different port. Now it uses a different endpoint, or a host point out on the internet to be able to get an update, to be able to get a package. And now this network needs to be allowed through. It needs to be allowed back in. This device needs to be able to communicate to this device over here on this other port. It changes. Things change. Stephen is intimate with everybody here, and anybody here in the room is intimate with one of the most significant user impacting things that came out of .1x, and that was the Xbox experience with students in the dorm. Now, what caused it?
Well, the short version is Xboxes used to have peer-to-peer connections, and they were designed to use peer-to-peer connections. So Xbox A talks to Xbox B directly. That had its own host of problems that we ended up solving a couple of years ago. Having more to do with IPv6 versus IPv4 and the stupid freaking protocol that Microsoft decided to put in the Xbox to make it work. But the larger problem that occurred last summer, so if you have kids last August that all of a sudden couldn't get onto Xbox Live properly, is because they changed it from a direct Xbox A to Xbox B pure connection to Xbox A goes out to Xbox Live, talks to the cloud, then talks to the other thing. That causes problems on every enterprise network that doesn't like, what is this thing? What is this weird connection coming in from outside, and why is it encrypted using a protocol that nobody recognizes?
More importantly, from the university's perspective, it was
a couple of years ago, having more to do with IPv6 versus IPv4 and the stupid freaking protocol that Microsoft decided to put in the Xbox to make it work. But the larger problem that occurred last summer, so if you have kids last August that all of a sudden couldn't get onto Xbox Live properly, it's because they changed it from a direct Xbox A to Xbox B pure connection to Xbox A goes out to Xbox Live, talks to the cloud, then talks to the other thing. That causes problems on every enterprise network that doesn't like, what is this thing? What is this weird connection coming in from outside, and why is it encrypted using a protocol that nobody recognizes?
More importantly, from the university's perspective, it was one thing to say, hey, it went out, we'll allow it back. You heard me say the word stateful earlier, okay? And in regards to a firewall, if you're sending traffic out to the internet, the firewall allows it back because it maintains a connection table. Unless you get redirected somewhere. Or in this case, it was UDP traffic, which is connectionless, and it was coming back in from a different host. And so the firewall went, I don't have a record of Stephen's Xbox talking to you, and you're trying to reach Stephen's Xbox. Have a nice day and go away. No. Basically, it needed unfettered access, into the inside of the network, which security was like, yeah, no, we're not doing it. Our solution we came up with 3540, which utilizes a one-to-one NAT, non-dynamic path, which is what most of the internet users experience here today on their endpoints. And we allowed some specific rules in, attributed to that group or that small group of users. They're going to be in a very narrow and very identifiable subnet for devices that are wired into dorm rooms. And that's the only place that VLAN is going to exist, is in the student's dorm room. Maybe a couple of common areas as well.
Right, so this is a cautionary tale sort of to the group that's here and on the webinar. If you have any sort of weird consumer device that you're using in your lab, pay attention to how it communicates, because it may have some weird port setting that it needs for something, just for whether it's for, because we have a very similar problem with peer-to-peer downloads for certain games, for example. The company that makes WoW, I'm blanking Thank you. Blizzard does T2P downloads for all of its updates on World of Warcraft. World of Warcraft is a very popular game, and what ends up happening, it didn't matter with Diablo, didn't matter if it was any Blizzard, anything uses P2P for its updates. So what ends up happening for almost every university anywhere that uses enterprise-grade networking is students are like, I can't get this new patch for this expansion, and they have to go off campus, download the patch, then come back online to download it because the university blocks P2P connections. So these are some of the fun consumer level user experience that I get to deal with, and Daniel Palmer gets to deal with on a regular basis with our residents.
Yeah, and one thing I want to add to what Steve is saying, just going back to my point earlier, is the deployment process. So the first thing we do when we move on to a new building is we work with the support staff to identify a room and a wired port within that room that we could use for testing. And then we activate the new environment in that room. And then we work with you to say, all right, let's have a brainstorming session. Give me every left field use case you have for users in this building. We bring the QA team in. We do proper quality assurance with test plans and documentation. We run through as many things as we can think of and try to see if we can break it. And if we run into something that's not working, then we talk about it and we talk about the best way to move forward. So my point is that I'm trying to make here, we don't just come in and turn it on and go live. We work with you, we test, we make sure that you're comfortable with the network being able to work with the different use cases for that building, and then we go live.
Yeah, and they've been, and I do want to give credit and kudos to Jim, not only for managing the project, but wrangling the sheer volume of requests and back and forth that has to go on to. So to give you some context, we started this for the Res Live started, about a year ago?
Yeah.
So about a year ago, and we have gone, and Daniel and I put our feet down, we put our line in the sand, and we're like, no. You don't get to turn anything on until we make sure that every weird, funky thing we can find works on this new NAC. And so what we did and what we suggest you do is, as Jim is saying, is find a room that has a couple ports in it that you don't need on a regular basis, that you can dedicate just to that. They will convert those ports to the new NAC, use those ports for testing, test every weird use case scenario you can think of, and then go find somebody else who doesn't know anything about it and ask them to test some weird things, because they will see stuff that you don't notice. With the Xboxes in particular, we had problems where we could mostly make stuff work, but there's still certain multiplayer games that don't function, not because of the Xbox, but because the games use different port assignments depending on the game. So that makes it more complicated. So we had a lot of problems with like Battlefront, for example. But similarly, we had problems with, we had to figure out VoIP phones. We had to figure out all of these different little pieces that all connect. If you have any additional signage, School of Engineering, if you have IoT devices that you're playing with, you got to figure those out. Any sort of robotics or wireless control, things like that, you got to figure that out. So, but just give them a room or two within a building or within the multiple buildings that your area is involved with, and they will work. And what they'll do is go directly to the switch. They will assign on the switch to the ports that you specify, and that's your test environment. And you go back and forth and back and forth and back and forth with your testing results. We're hoping that ResLive, having been the guinea pig for about a year, with a good mix of offices, faculty and staff, classrooms, imaging needs, regular support needs, and residential. That's part of the reason we started with ResLive, because we had such a big mix. So hopefully we've covered as much as we can, but there's going to be stuff that we don't have any experience with that will potentially affect you guys. But Jim has been fantastic. He's always open for questions. The project team, High Tech, is very responsive. I've had conversations with them by chat and email at 10 o'clock at night for something weird. So it's a good team. They will go slowly, building by building. But do your testing, do your due diligence, because it will be the thing that you never thought of that will come back and bite you.
Thank you, Gary. In full disclosure, I did not pay him to say that.
I actually did. All right, we got a few minutes left.
Final shot. Do you have somewhere a list of when you will probably be going to which buildings, so we can be aware of the fact, well, next month we're going to need to be working with you guys?
Yeah, I don't have that list yet, and one of the main reasons is so there's, well, as you guys probably know, there's about over 1,100 physical structures on all campuses. We've got that narrowed down to about 85 deployments that I think we're going to be able to do. What I'm fighting for right now is resources. So if I have the existing resources, it may be sometime between now and 5 years. If I can get more resources, it'll be sooner. So once I get those locked down, I'll have a better idea of when we can get to you.
Okay.
So, yeah.
But typically,
I'll follow
you
that.
would be forewarning people about how far.
Yep, oh, absolutely.
Okay, a week a month.
At least 30 minutes notice.
Yeah, no, we'll once we get that a little bit more nailed down, I'll make something available, probably put it on wi-fi.asu.edu. Like I said, we're gonna update that to have wired information. And, you know, it'll probably say something, here's the rough guess as to what our schedule will be. It may change as necessary because, like, for example, like what Steve was saying, I know we're getting close to the end here, so I'll wrap up here, but we may have something on the schedule, say that we want to, approach and deploy maybe a month out. We get in there and we set up a test environment. We say, wow, we got a lot of stuff to work on here. So, so the idea is that we'll be able to work with a couple buildings in parallel, and one might be a pretty straightforward deployment, and one might be a little bit more of a challenge. And so we'll have to move the schedule around for those types of things. So we'll have a couple of different work streams going on. Here's some deployments that are going on. Testing is completed. Testing, working with you on these, and
Yeah.
So, yeah, but yeah, we're going to try to be as transparent as possible.
I'll close out with this as well. We're not going to leave you broken. We commit to your building and something doesn't work. The shortest path of resolution, okay, is post troubleshooting. If it's one of those, I have no idea where to even start. Is go to the switchboard and go click. That one X is off now. Plug in. Okay, we'll put you on the VLAN you need to be put on. It'll be a use case that gets worked in the background, and when we're ready, we'll come back. Right? I'm not going to leave you broken. We run into this where that's the exception and not the rule, then we're going to back the entire site out. We're going to take it back to the state we're in. Okay? We're not going to leave you broken. We're not going to leave you guys, any of you in the room, or any of the users out there we're not even talking to, in any way, shape, or form, broken when we're done. Great. All right, a few minutes left. Troubleshooting. This is probably the most important slide in the deck, and we're going to go through it the fastest just because. Confirm the basics. Okay, when you're talking to a user, whether you're a service desk, whether you're a field tech, whether you're desktop support, whether you're just Steven who happens to be in his office when somebody stops him and says, my stuff doesn't work. Okay? What devices? What's the hardware? What's the OS? What's the Mac? If they got an IP, get it. Why? Because that's going to be important in determining if they're landing in the right spot based on their role or if something's failing.
Just point of clarity, make sure to get their wireless and wired IP address and MAC, because particularly if it's a laptop, it can still be on wireless and they may pull up the wrong thing if they're trying to pull an IP config. So capture everything.
Not Bluetooth?
Not Bluetooth? No, Bluetooth is a whole other problem.
How are they trying to get on? Are they providing credentials, or do they think the device is MAC address bypass? Right? If they are trying to do credentials, what credentials are they using? I'm not asking you to give somebody, asking them to get a password. Don't put a password in the ticket. Get their user ID. Get what they're using.
For the MAB, the service desk ASU help desk actually has a pre-built query that they built, so you can look to see if a device is registered in the MAC address bypass. If it's not in that pool, MAB isn't going to see it. And sometimes devices will fall out. There's a time limit on that. I think it's for a year, so 365.
365 days.
So 365 days. So if you're like me or John Rome and you have an Echo in your office and you registered it last year, and then you hit the date, it falls off, and then you have to re-add it.
Now, I will put a small caveat to what Stephen just said. It will not authenticate again if it becomes disconnected. Okay? Why? Because it's no longer in the database. It says, yeah, let it on, it's good guy. If you don't actually lose connection, you don't go until it does. Okay? So while we purge that database every 364 days by host or by address, we're not bouncing those users. We're not bouncing those devices. Okay? So it's a static device sitting right here, not moving, always connected. Not going to go down. Reboot it, turn it off, loses wireless connection, and you're going to get it back on.
Or a lot of IoT devices have a built-in timeout if they're idle for too long.
Who are the users that are trying to get on? Are they students? Are they staff? Do they have rights? Do they have rights to what they're supposed to get to? When was the last time they could get on? When did they last attempt to connect and authenticate? What was the user experience? The details matter. They absolutely matter. I will give you a brief example of something that was reported, and as it turns out, erroneously reported. Student wireless is not working. True or false? We have student wireless. False. We don't. It's just staff and us. But what we do have, as everybody knows now, we have a different subnet that we assign students to and we assign staff to. Wireless is down. That was the report. Now, as you might imagine, everybody's going and looking at wireless. Central Link's looking at the WLCs and the APs. We're looking at ISE, and we're not seeing anything. But the users were down. We actually had to recreate it. We actually worked with CenturyLink, I should say, recreate it. They put a device on, or put an AP on a controller, put the device specifically on 3520, and realized that, students were on wireless. What they couldn't do was get out to the internet. Okay? Now, you might imagine this was, 10 or so people troubleshooting for a couple of hours to the net effect of zero. What it turned out to be was the students who were landing in 10156, I believe, were being passed out to an address that was being blacklisted by the university's monitoring system. And so they weren't getting out to the internet. They weren't even leaving. That was the problem. Now, how could this have been troubleshot better? The user is going to tell you, my wireless is down.
What do you mean?
Is it?
Wireless down?
Right? What can you get to? When you connect, what can you get to? Can you get to your printer? Can you ping this? Can you reach something within the university? No? Okay, and you're definitely not connecting. Oh, I know, I can reach something in the university. Okay. So when you say it's down, what are you trying to reach? What are you trying to get to? Well, I was trying to go out to Facebook. I was trying to go out to CNN. I was trying to go out to something on the internet. That's not working. Okay? What could it be? Could be name resolution. Could be DNS. Could be firewall. Could be, in this particular case, CF5, blocking. Details matter. Counting and capturing the user experience and understanding the questions to ask and the details to provide. No such thing as too much info. No such thing. I'll read through it all. Troubleshooting, why do we need those data points? The failure to connect, as we talked about today, may be expected behavior based on your role, your group assignments, your OU memberships in Active Directory, and where you landed and what security rules are in place. It may be completely expected. You may be a blacklisted device. Your role may not allow authentication. We repeat that. Your role in the university may not allow authentication. Graduate students, their Active Directory accounts are still there, but you can't use it to sign in the wireless. You're going to follow the data together, verify the experience if you can. Again, no such thing as too much info. Some glimpses of the troubleshooting tools. That's an ICE dashboard. Shows total authentications, network devices, endpoints. That number right there, not a typo, 956,000 different endpoints at one point or another have connected to ICE in 2 years. Active endpoints, active groups, BYOD, or your own device, otherwise known as non-domain joined, non-ASU assets. There's a quick report as an example of MAC addresses that are connected or not connected, as the case may be. Again, just details. Thing you're going to see here is, Stephen pointed out, that's the most important piece of information you're going to get if you can get MAC address of the device. Here is what raw Splunk looks like. For those of you who have used the help desk or service desk query function, this is what it's sucking out into a kind of easily readable form. But it's going to tell you everything you need to know about connection attempts. Username, MAC address, why they failed. Okay? Now, does that mean they were using the wrong password? Likely, not always. Okay? Sometimes the policy node is not communicating well with the factory directory. Fairly rare, but it happens. Tough to read unless you're used to staring at it. That is what the service desk dashboard looks like. Okay? A lot easier to read. Tell you failed attempt, why, or what the message text was, what the resolve group was, the username in this particular case, that is trying to use machine on. And it's a failed attempt. I'm going to extrapolate why, because he's not right.
By the way, anyone can request access to this. You just do it through ServiceNow, request access to Splunk, and you can specify that you want that dashboard.
It's going to tell you things, too, that you're not going to be able to do much with, other than, okay, there is a rule in hit. The ISE policy set, okay, Wi-Fi secure access. What does that mean to you? Nothing. I mean, it'll mean something to us, but that's the rule set of hit, okay? And the rule set in this case that failed said, look here for device membership and machine on. I don't see this device name, so I'm not letting you on. Wireless guest nav. That device is MAC address bypass. You can almost always tell when a device is configured to use MAC address bypass because it's using the MAC to try and authenticate. That giveaway. Troubleshooting, requesting Splunk access. There's a how-to. We are at the end with a whopping 11 seconds to spare. Questions, thoughts, comments, feedback. You should all know how to get a hold of Jim. I've given you some info in terms of how to get tickets open to us. Even if it's just informational, and if you've got a question about how to go about doing something. There's a ton of KB articles out there on ServiceNow, and the service desk is really gotten accomplished at fielding the vast majority of the wireless issues that come up. The number of things that spill over to us on a daily basis is really small. By and large, it's things that are usually super innocuous. It's things that they're going to look at the tool and go, I don't know what that means. I definitely saw. Hopefully you found this somewhat useful and informative today. As I said, I'll make sure that this is available online to everybody. And in the meantime, as Stephen said, we usually try and be pretty prompt at responding. So if you've got a question, comment, need some information, please don't hesitate to let us know.
Thanks for joining, guys. We look forward to working with all of you. And like Tony says, don't hesitate to reach out to us if you have any other questions.
Thank you.
Thanks, Dan. Have a great day.
Thank you.
Okay, thank you.